Hello everyone, my name is Hunter, and today I'll be teaching y'all a tabular mnemonic on how to interpret iron studies for med school exams. I've compiled information from first aid, pathoma, and amboss onto one singular table of relevant info shown here. First, in this video, I'll be demoing how to recreate the table with the use of some mnemonics I come up with, and that's all y'all have to watch if you're just trying to cram this in a pinch. But if y'all are curious on my methods of how I developed the table, then on the back end of the video, I'll be explaining more of the pathophys of what the table means and how I came up with it. Check the description for timestamps, and let's get this started. Alright, so when constructing the table, we're going to remember the letters D, I, and O. And these stand for iron deficiency, chronic infection, and iron overload. And now we're going to be getting the four rows. So we're going to remember F, T, and then S and S. And so these stand for ferritin, transferrin, serum, iron, and percent saturated transferrin. And so now we're going to be filling each of these row and column combinations with either up or down arrows depending on the disease state. So the way I've constructed this table is that you only have to memorize one of the columns and then you're able to figure out what the other two columns are based on one singular column. And so in my case, I have memorized that in iron deficiency, there is decreased ferritin, increased transferrin, decreased serum iron, and decreased percent saturated transferrin. And now going from left to right, we're going to be flipping the direction of the arrows here and here. So going from left to right, from iron deficiency to chronic infection, we're going to have an increase in ferritin, a decrease in transferrin, a decreased serum iron, and a decreased percent saturated transferrin. And then going from chronic infection to iron overload, it's going to be an increase in ferritin, decrease in transferrin, increased serum iron, and increased percent saturated transferrin. Now, what you can hopefully see here is that iron deficiency is the exact opposite of iron overload, and then chronic infection, half of it is opposite to each of these. So once more, if you just remember one of the columns and you know when the signs are supposed to flip, then you're able to derive all the information for the other columns. All right, so that's cool and all, but there's still more information we can get out of this table. So each of these columns is going to be associated with another clinical scenario where iron studies could be relevant. So in iron deficiency, this is going to be related to pregnancy/oral contraceptive use. And in this case, we are only going to care about the things that start with the letter T. So we only care about the transferrins. So in pregnancy and oral contraceptives, we're going to be seeing an increase in transferrin and a decrease in percent saturated transferrin, and we don't care about the other two. One way to remember this is you can think of the word pregnancy. So pregnancy, in pregnancy and oral contraceptive use, we're only caring about transferrin and the percent saturated transferrin, and it's going to be very similar to the iron deficiency state. And now, for the chronic infection column, the similar clinical scenario is going to be acute phase reactions. And in this case, in acute phase reactions, we're going to be seeing an increase in ferritin and a decrease in transferrin, and we're not caring about iron or percent saturated transferrin. Now, the relevance here is that in acute stages of infection or inflammation, we expect to see increased levels of ferritin and decreased levels of transferrin. And now lastly is for the iron overload column. And in this, we're going to be thinking of different diseases that have O's in them. One is sideroblastic anemia and also hemochromatosis. So in sideroblastic anemia and in hemochromatosis, we're going to be seeing iron lab results that are similar to iron overload. So in all of these, it's just going to be the exact same. So yeah, by organizing the table in this way, we're able to draw a lot of similar trends of information for these 7 different clinical outcomes for their 4 lab parameters that are related to iron levels. So as some bonus mnemonics, if y'all have trouble memorizing this table, with regards to the iron deficiency column, instead of having to memorize down, up, down, down, if you treat a down arrow as a number 0, an up arrow as a number 1, then you get the binary number for 4. If y'all are familiar with binary, it can be really useful for unpacking a lot of tabular mnemonics. Another thing, of course, is if you just watch the pathoma video on microcytic anemia, you'll probably be able to understand iron deficiency well. So the iron deficiency column at the very least should be easy to recall. And also if you're trying to remember which things flip where for the first row with ferritin, D, I, O, you can think of D for down, I for increase, and then O for overload. So if you have trouble remembering that the flips happen here and here, that might be helpful. So now I'm going to go on how I came up with this table, but for the rest of y'all, I hope you found this useful, and good luck in studying. Alright, so the reason I wanted to make a new iron studies table is that a lot of resources med students use to study for exams will either emphasize different diseases, or they'll just have slightly conflicting info for the lab values you'd expect in those diseases. So for example, in the iron deficiency columns and chronic disease columns shown here, there's slight variations in the arrows or dashes given with each lab value between the resources of Pathoma, First Aid, and Amboss. So I just wanted to make a table that included everything and was just simpler to recall. So for my table, I just went with whatever the majority of resources said for each lab value, and then simplified it to either have a single arrow or just a dash. And if there were any disagreements with the content, then I just chose to give Pathoma priority because Dr. Sitar is the GOAT. So with those methods, this is the big combined form of the table I ended up making. And if you aren't familiar with each of the lab markers, watch the Pathoma video on microcytic anemia. It does a great job of motivating the importance of each of them. In short summary, ferritin's the main storage protein for iron, transferrin's the main transport protein for iron in the blood, which I just use interchangeably with TIBC, the indirect measure of transferrin. Serum iron is the actual measure of circulating iron in the blood, which is primarily bound to transferrin. And lastly, the percent saturated transferrin is equal to the serum iron divided by the TIBC. And so for the columns, I noticed that there's approximately 3-ish groupings of similar lab values for each of the clinical scenarios. So there's the grouping for general-ish iron deficiency, the ones related to infections, and another one for things related to iron overload, which you can see here. So of course, with iron deficiency, you just don't have enough iron intake or absorption to meet your bodily demand, so you're becoming deficient and you're having a lot of symptoms of anemia, stuff like that. Pregnancy is pretty similarly related to that because you need a lot of iron for the baby and it's more likely to run out. And oral contraceptives, just empirically, were found to be similar to that, and I guess they expect us to know that. And then for acute phase reactions and infections, so transferrin and ferritin are markers of acute inflammation. So ferritin's going to increase, transferrin's going to decrease as to keep iron away from pathogens. But, if you have these processes going for so long, you're going to eventually deprive your own cells of access to iron, because normally transferrin is going to be what helps bring your iron to the tissues. And so if you have all of it in storage, not enough access for your own cells, you're going to have the anemia of chronic disease. And lastly, with the iron overload grouping, the body can only really regulate its total iron concentration with the steps of absorption of iron into the bloodstream. It can't really control to easily expel a lot of iron if you have too much. So iron overload is probably just going to be you ate way too much, took way too many supplements, things like that, or got a lot of blood transfusions from someone who was rich in iron. But for sideroblastic anemia, in making hemoglobin, you need to combine heme and globin. And heme is going to be resulting from iron plus protoporphyrin. And in sideroblastic anemia, you have a bad form of protoporphyrin, which could be either from something like ALA synthase or for some issue with vitamin B6, which is a cofactor of ALA synthase. The rate-limiting step in the mitochondria for making protoporphyrin for hemoglobin for RBCs. And if a genetic issue or an acquired issue, so that can be ethanol, lead poisoning, B6 deficiency because of drugs like isoniazid, chloramphenicol, etc. You have messed up protoporphyrin synthesis, and so all of the iron you're trapping into the mitochondria, it's just accumulating in these edges of the RBCs where the mitochondria are. You form sideroblasts on histo, and so your body doesn't have actual good functional use of iron. So your body just keeps trying to increase its own intake of iron, which is what leads to iron overload, even though you should have sufficient iron. So with sideroblastic anemia, you would have a normal amount of iron, but you just keep taking in more and more because your body can't use it correctly, and it doesn't realize that. With hemochromatosis, so probably like a mutation in the HFE gene, transferrin can't bind to transferrin receptors, so you have decreased hepcidin production, and the body therefore can't negative feedback on the absorption of iron from the digestive tract, and therefore you're going to have too much iron intake and you can't get rid of it fast enough. So iron overload is just going to be that you have too much iron either because of too much absorption or because of a blood transfusion that gave you just way too much. Hemochromatosis is going to be because you had some genetic issue which made it so you can't do negative feedback well on the absorption of iron. And then sideroblastic anemia is you would be at normal iron levels except for the fact that your body just can't make hemoglobin properly, and so it keeps thinking it needs more and more iron in order to combat this defect, which is what leads to having lab values associated with iron overload. So in summary of this slide, there's these 3 major camps of things related with iron, either the deficiency camp, the infection camp, and then the overload camp. And I noticed that it can be condensed into this form here, where we have the main arrows for all of the groupings. And then in the more specific clinical scenarios, we were able to have this more condensed form where for each of the clinical scenarios outlined in red, they only care about the values that aren't crossed out in red. So I hope y'all found this useful. Let me know if you have any feedback or any questions. Thanks for sticking around to the end, and good luck with studying.